Let me start by just thanking Mike for that really great introduction and explanation for what we think of as cognitive AI or the cognitive approach. Ron and I wanted to make this very conversational, so we're going to step out and walk down there, right? And we'll talk. So it's a small crowd. It's intimate. We can make this really more of a conversation rather than a.
We're passing the offer plate.
That's right. So welcome to the Ron and Shelley evening show, as before, right? So let me start by, Ron, do you want to introduce yourself?
No, it's fine. Let's just keep going.
Okay.
We have
Shelley,
a little time
Nandkeolyar.
and we have a little bit of time and a whole lot to go over.
So we both come from a very business-oriented background. I've spent 20 years in e-commerce, launching different businesses in e-commerce, and I've always been a student of applying e-commerce kinds of techniques into different kinds of businesses. And so we kind of accidentally fell into this space, I'd like to think. And it was a sort of a very happy circumstance that I found myself with Ron working on projects like this and really getting excited about it. So what we're going to do is, we're not going to try and sell you anything. We're just sharing stuff that we're working on. Invite your participation from a dialogue perspective, from questions, from conversations. And hopefully, we're hoping that this will also create some buzz that will help enlighten us in some of the things we're doing. All right?
I will say, though, that if you look at the title, we call this a journey of necessity, and we're going to kind of explain why we call it that in just a few minutes. And it's just a brief case study of we came up with a concept and how we put it through to fruition, and then some of the results of the pilot that we ran to prove that it worked.
I'll stand alongside my name. That way I'm not on the stage there. Okay.
All right.
All right. So often when we talk about GP, people think we're Georgia Power or we're a train company or something else. But just to set the record, we're the paper company. We're based out of Atlanta largely.
Yeah. We have about 150 manufacturing sites around mostly North America. We have a few elsewhere. Around 30,000 employees, about 25,000 of those are in our operations. And we are headquartered in Atlanta.
All right.
But we cannot, if anybody needs to get plywood, we can't help you with that.
Yeah. We're not taking any lumber orders tonight.
We are the number one manufacturer of plywood, but I can't even get it, and it's still $120 for me to get it. So
but there may be a couple of other people in the audience who might take some orders. I don't know.
Okay.
Here we go. All right.
So a couple of years back, we did a study in 5 of our largest facilities, and this is relative to the personnel curve that we saw. You got the clicker. Mm-hmm. Which one is it?
That one.
Okay.
No, the other.
Yeah. Okay. So you had shipping and receiving, manufacturing, maintenance trades, process technicians, SMEs, and this is what it was. The thing about it is that when we did this, we noticed that in 2023 and 2024, a lot of our SMEs, a lot of our people are going to be retiring, and everybody's going through this, I'm sure. But we had 45% of the people that had been with us for 20, 25, 30 years that created this big hole. And so the personnel curve was going to look like this. And so the problem with 25 and 30-year-old duration employees going out is that the knowledge leaves. And then everybody's, I know, raise your hand, right? Because we're all in the same boat. But when that knowledge leaves, is that we have to replace it with somebody that's just out of school, or either steal them from your competition, and you can't steal that many, right? Mm-hmm. So we have a problem here.
And then another part of the organization, obviously, we're talking about, customer management, customer centricity, customer obsession. How do we really sort of build relationships with customers that transition them from being sort of adversarial, if you will, into being more partnership-oriented? And how could we really get them into what we call into an ecosystem where we change the style of dialogue, change the style of partnership, and move them from being people we negotiate and work with, but really brought them into what I would call a mutual cycle of benefits for us and for them, where we could really draw to both our advantages.
Right. And so these are some things of transformation initiatives that over the last couple of years that we've been working on. the other one is this, and our team leader, Mike Carroll, is going to talk about this in more detail in the morning.
Mm-hmm.
But this right here is really a huge problem. And again, Mike's going to talk about it in more detail. But over the next 8 years, data is going to increase tenfold. And I got to tell you, with 150 manufacturing facilities, the amount of data that we already have is staggering. And when you start talking about it's going to increase 10x, how can humans do it? How can we physically do it? We can't physically do it. So we said we have got to come up with a solution, and we need what at the time we called a digital business companion, something that could help our employees in the roles go through their day, but make their days a lot easier than it was yesterday, right?
Mm-hmm.
So when you look at AI, and Mike did a good job explaining this earlier, and there's several different forms of AI, but this is a good example of traditional AI model. And in this example, we're going to talk about the supply chain because that was the pilot that we did. So as we go through this, we're going to talk about the supply chain. But you have an engine. And in the supply chain example, this engine looks at the customer data and it looks at the supply chain data. And then it looks for correlations between the two. And it says, okay, this correlates with that, and there's a good probability that this would happen or a good probability that this would happen, not a good probability that this other thing would happen. So it's more based on correlation. And this is great because we need this, right? We wanted to keep this. But we went and talked to the biggest and the medium-sized companies and some of the smaller companies in the Northwest and in the Northeast and in Asia and in India. And we told them that we had this concept. This is traditional AI. We want to add knowledge to that so that the system knows what part of our enterprise it works in. And it also has the knowledge of the best people that work in there. And so when you go back to our previous slide, when you see that personnel curve, all those people retiring, I have to capture that knowledge somehow. So this became the way for us to do that, right? So it depends on what business unit that we're in this case, the supply chain. And so the subject matter experts teach the system how they do their jobs. And actually, we told them to tear it down because we do interviews with them. And we say, look, if you could start over and if you could make this the way that you would want to make it, how would you do that, right? And so when you're interviewing just one, you have bias. Two, you still have some bias. But when we interview like 10 about this is exactly what these people want, and you'd be amazed at what you will hear, right? As opposed to us calling in big consultants to come in and then determine what should be happening tomorrow and what should be happening next year. People that do this job every day will tell you because they are the experts, right? Now, this has got a lot of stuff on it, but it's basically the same slide as this, just expanded.
Mm-hmm.
So I want to explain a little bit about how this works. So first of all, it's modular, meaning that in this instance, we taught it how to work in the order management part of the supply chain because we actually had a little bit of a challenge in that part of our supply chain. We were getting about 9%, a little 9.5% of our orders going through touchless. And so if you think about how you're going to do business next year, and the year after that, and the year after that, you can't really do it functionally with 9% orders going through touchless. We need it a lot more. Mm-hmm. So that was one of the things that we wanted to tackle. So I'm going to give you an example of how this works. So an EDI order comes in. It comes into the brain. So this collective intelligence engine, we call it collective because it's a collective of the intelligence of a lot of people throughout our enterprise. And so it sits between the customer and the ERP. So the order comes in, the system says, okay, I've seen this before, I don't have any problems with it. The thing is that it it's programmed to first look at the customer. And it's an expert with this customer. It knows every one of our customers. It knows their strategies. It knows their failure options. It knows that when we get an order in 5 days ahead of time, that this customer expects it to show up between 11 o'clock on the day that it's supposed to get there and 2 o'clock in the afternoon. And if it doesn't, then we get a penalty. So it knows it's got to get this out on time and in full to the customer. So this brings this customer and puts them right in the middle of our ecosystem. So it looks at the customer and it says, okay, I know this customer. I know what's going on. If everything's fine with the order, we've got it, the inventory, it's not a problem. It will send it through to the optimizer, and then the optimizer sends it to the ERP. So this can be a batch of 1, or it could be a batch of 10,000 at the time, or more. If you have more that come in, it takes a look at all of them. First looks at the customer. Then it knows where in the enterprise it's working. It looks at the supply chain knowledge about what's going on in the enterprise. And then it has the SME business unit knowledge. So the order comes in. If it has a problem, this is the cool thing. If it has a problem, it's going to write a hypothesis about what it needs to do with this order to get it through 100% on time and in full. If you've got 10,000 coming in at the same time, it's going to do the same thing. So you could have one really long math problem with a lot of things to go through. And it writes this hypothesis. It says, okay, if my job's to get it 100% on time and in full, then I have some options. Option number 1 is what I really think is the best option, but there are other options. And it's looking at everything at the same time. What's the best way to fit all of these things with the inventory that we have, with the shipping capacity issues that we may or may not have, and to get it to on the freight on time. So it looks at that, and it runs this hypothesis. At the same time, it has a twin of this whole system. And the twin is working through the alternative possibilities. You want to talk a little bit about the alternative possibilities?
Right, but just a couple of other points that Ron made. So in terms of, so think about a batch of 10,000 orders that are being optimized simultaneously across all the customer priorities ranked by their importance to the company. And that's the kind of computation humans can't do. You can't have all that facts in your head to manage it. So it really sort of decomplexes the issue and makes it much more computationally capable to execute on. So the alternate possibility is really the idea that sometimes it may see issues that it has not resolved before. And so what it would do then is develop a hypothesis around how to resolve it on the fly, create some optionality on it in terms of recommended ways of solving it. And then it'll either resolve it, or if it doesn't resolve it, I'll show you on the next slide what it does. It pops it back up as an issue unresolved for human intervention. And then once the human does resolve it, it goes back into the pool as a learning mechanism for the system to pick up for the next time.
The other thing I did got to mention is that when the order comes in, it looks through all of this, and then if it's something that it hasn't seen yet, it will go to its knowledge banks and said, okay, the SMEs say this is the best way for me to solve this problem, right? Or these problems, plural. And this is the particular data that I need to go solve that problem. So, even though the big giant stack of data may be available to it, it grabs what it needs out of the stack and then solves that particular problem and moves on to the next thing. In real time, all of them are doing it together. But this alternative possibilities is it thinks this is the best way to do it. This is the best way to solve these 10,000 orders. But it's going to check itself, right? Some people call it, looking at alternative possibilities. It's really validating whether or not it's made the right decision, right? And so it's this twin is now going to go through and say, okay, the first time I chose this for this particular order, and it was a little bit shaky, so I'm going to try this. And then it's running all of these models in real time to see, did I really make the right decision or did I not make the right decision, right? And so within a matter of just a couple of seconds, if it needs to update the hypothesis, it does. If it's not, it sends the hypothesis to the optimizer. The optimizer lays everything out, looks at the freight, checks all the freight, everything's good, and then sends it to the ERP. And so this is kind of how it works. There's another way to look at it.
Yeah, just give me that. Thanks. Okay. So Ron walked you through the sort of the construct and the model behind it. So put this in a typical environment of an order coming into a large company. And most companies have an ERP, which you see down here. But typically in each case, let me go back. I'm fat fingering this. It's not working.
Hold on, I'll Vanna White it for you.
Yeah, there we go. There we go. So look at what Vanna is doing. Stay there. No, Ron's walking away, I'm sorry. But anyway, so what typically happens is the order comes in and it goes to the ERP directly. Now, as many of you know, most ERPs are set up with their own business logic, and they typically end up rejecting an order, and they may have multiple different blocks that might stop it from going all the way through. So what we have is a system where it comes, when the order comes, we intercept it. We have this cognitive engine that Ron was just describing. It has the ability to not only know the customer, its ranking, its rank order priority, what kind of products it typically buys, what is the typical fulfillment targets that we achieve for them. And then not only that, but also has the ability to look ahead into a 9-day window, to look at what other orders are in the pipeline, what is likely to come, what is likely to be the best optimization for this order.
It could be 30 days ahead, but we chose 9.
We chose 9 days because that's typically most people place orders and in a 5-day window, expecting to be sort of delivered on the 5th day. So we picked the twice as that length kind of period. And then what it does is it looks at all the orders and looks at all the potential blocks. And we've sort of called blocks as impedances. And what it does to do is try to detect all these and then goes back to try to resolve them. And what it typically do is come back with either a solution that meets our requirement of 100% on time in full. So not 97%, not 96, not 99, 100% in full, and then puts it through to the ERP for fulfillment. And it has to be touchless entirely, so there's no intervention, no one's touching it. There's no sort of solutions analyst requiring to touch this order. It goes all the way through.
What happens if it's like 95%?
Right, so if it's 95%, thank you, Ron, is what it would do is it would sort of kind of put it into a CSA loop. So it would then push it up as a recommendation for human intervention. And typically the analyst can go in there and look at it. And it's just not just pushed up without a problem. It's not, sort of not a dead fish on the table syndrome. It sends it with 3 different options. And it says you can fulfill it this way, or this way. You pick. It also gives you the ability to customize it. So it says you don't want to use any of these. You could take one of these as a base and do a customization of it. And that becomes a learning loop. So when the CSA makes a pick or a decision on which way they want to go, they restack the order goes back, the cognitive engine picks up the learning from there, and then puts it back in queue. And it has to still meet this objective, 100% on time in full. Now it's no longer a touchless order technically because it's been touched. But the thought about a touchless order really is that when it gets into the ERP, there are no blocks, there are no issues, you need no resolution time. Yeah. Typically, in a situation like this, in most CPG companies and large companies, it could take a couple of days to resolve an order. Yeah. All this is happening in near real time.
Yeah. So that is a big deal. When you think about on average, an order may get blocked 4 times, 5 times. Yep. A human has to touch it every single time, and it sends it back to the ERP. ERP has another block. The solutions analyst has to fix it. Goes back through, hits another block. It's 2.9 days was the average that we found, right? So you can't do that. So when it sends this through, it's going to come over here. It'll tell the analyst, here's this order. Here's what the problem is. here's what the problem is, and here's the way, as Shelley described, the best way that I can figure out to solve this problem. And it's looking for human validation. I think this is the best one, but what if they pick option 2? And as Shelley said, it gives it an opportunity to learn because it's going to ask, why'd you choose option 2, right? So not only did the SMEs teach it how to do it the best way, it's continuing to learn now with every transaction that goes along.
So I think all this happens, and what we've done is, so if you think about, everybody talks about UI, UX, and how does the associate really deal with this. So what we have is a workspace. It's not a dashboard because it's different in the sense that it's actually taken action on a lot of things. So the numbers you see here are sort of relatively correct. So
I changed these numbers.
You did, but
well, because they're proprietary too.
Right.
Because this was real data. So I'll tell you what I did. I changed the numbers, but the ratios are still the same.
Right.
Okay.
So if you think about, so the example, and I think Ron's point being that essentially, if you take the body of orders being about 3,700 orders coming in.
And this was on the 12th day of the month.
Right. Only 3 of them hit a point where they needed to be escalated or needed human intervention. And all the others were resolved. This is pre-groomed, means it's in the status of being groomed. These have been groomed and sent to the ERP for processing. And then you had all the visibility for each of these orders at every level. So you could tell by the various construct, what customer, what brands were in that packaging, what areas it was being shipped at, et cetera. And then in real time, you have all the other information to look at, including what's in transit, where the customer orders in transit. Now, STO is internal stock transfers, et cetera.
Stock transfer.
And then the weather map.
So it's looking, it's again checking to see, is there still something else that could mess with my order to keep it to being 100% on time and in full? So what about tornadoes in the southeast? Okay, well, doggone, that could affect it.
That's right.
And it didn't think about that, earlier. So it's looking at that. It's looking at all the trucks on the road in our system at the same time. And sometimes with all the trucks that are coming in, bringing us raw materials, and all the trucks that are going out, you could have 12 or 15,000 trucks on the road at any moment in time.
Mm-hmm. So I think the key thing here is doing this sort of really ended up transforming the work people were doing. So they were no longer spending 90% of their time fixing orders. They now had that time free up to them to do what they really were hired to do, which is be analysts and thinking about how to improve the quality of the business, how to try out different scenarios or different kinds of approaches to managing the business. Yeah. So I think that's the more exciting stuff, right, Ron? Yeah. So you want to take this?
So they're analysts, and that's what they're paid to do, as Shelley was saying. And so now that their time is freed up, the system has the second part. And this is what's going on live in the system at any moment in time, right? This is the twin.
And the numbers are being redacted to protect the guilty.
Yeah, it's the same. It's the same thing. I can't put it up there. So, but this is the twin, and we're going to come back to this in a minute. Mm-hmm. And then this is discoveries. So, do you want to cover discoveries?
Sure. You want
go ahead. Go ahead.
You can have a go if you want.
Okay. Well, yeah. So discoveries is technically another digital twin, and it's looking ahead of what potential impedances could be presenting ourselves. It's looking ahead a lot further than what the 9 days was earlier. It's also looking behind. It's saying, okay, of the orders that I sent to the humans, how could I have done that better? And it's trying to relearn it yet again, right? So it's saying, okay, of all these orders that we sent through and X% that I had to send to the humans, how could I have done that better? So it's trying to teach itself now how to be better. All right. This discoveries is pretty cool because it'll give us an alert. And this is an example of the alert. We're going to have a shipping capacity problem on the 29th and the 30th of April. And again, this is the 24th. So it's going to recommend a 120% increase in shipping capacity.
So what that really means is as you know, DC has labor components, and they have a certain amount of staffing that's available to them to do a certain fulfill on a given day. What this is actually projecting out and saying is, hey, on this day, you've got too many orders that are going to bottleneck this place. And if you really want to stay with the plan, which you can, you'll have to preempt it by hiring more temporary staff to deal
Another
with
shift, whatever.
another shift or something, right?
And so we click this, and it gives us all the data that it used to come up with this scenario. And so we take this, and me as an analyst, I could use this data, or I can go in here and modify it if I want to. So when I had this, let's say that I said, all right, let's just use it by itself. We can start a simulation. The simulations will always run on historical data, right? And so it says, okay, here's what's the ending of the simulation. And as an analyst, I can say, you know what, this looks pretty good. I think I can do this. That's when we promote it to the twin. Because the twin it's not a mirror, it's actually a whole nother module, instance of the live version. And so we put it into the twin. Here's an example of this. So we had a large customer say to us, and I think I used this example before, we normally give them 5 days in advance to send us an order before it has to hit their distribution center. They called and they said, we need to change that to 4 days, right? And this is a huge customer. So when a huge customer with that much volume going through your supply chain wants to change that, well, that could not only just affect them, it could affect everybody else in the supply chain. And so you run a twin on that. And then it tells you at the end, okay, here's what's going to happen. Here's what's going to happen based on historical data. Here's what's going to happen based on things that are in the supply chain right now, right? And so now these analysts actually get a chance to do what they love to do, which is being analytical and being paid to be analysts and being analysts. Because that was for a little while, it was a tough job because they came in. Anybody else is going through personnel issues right now. They come in as an analyst, but they were basically order pushers. They're just trying to get the orders to go through, right, Mark? That's what they were doing. And so now they actually get a chance to do what they love to do, which is go look for problems and help solve the problems. Shelley?
Yeah, I think this is sort of one of the most exciting revelations for us when we did the pilot and we used the DC and ran it for a month, had this system run it. We saw incredible improvements. So touchless orders, they went from 9% to 91%. So that's essentially 1,000% improvement. Our second metric that we were looking at was basically orders with zero blocks.
Orders with impedances.
That's right.
Reduced by 61%.
And then penalties, which is, whenever you're late or not in full, you get charged a penalty, a reduction of 74%. And then finally, I think the last one we looked at was the on-time.
In full, order complete, increased by 26%.
So that was kind of the test of, can this really hunt, right? You kind of build these things, but when you put them into the dressing, can you really perform? And so we had some really strong performance metrics come out of it.
So I think we're running out of time. But here's the thing. We're not selling. We're not selling.
Yeah.
We just wanted to come in and show you guys how it worked, how the concept was, and that we actually were able to make it work like that. It uses knowledge to tell it the data that it needs to help to go solve the problem. And it's a little bit different than what traditional AI is. And we believe that this is going to be one of the key things that's going to help us go through this exponential data crisis that's going to be coming up. We don't know everything, but we're trying to learn.
Yeah. And I think if you think about companies that are really doing this well, there are quite a few out there that are doing some really smart stuff with this.
That's right.
And we're trying to take some of that learning and put it into more of a traditional legacy B2B situation and see what we could do with it.
Right. Yeah. Thank you.
Well, thank you. Yep.